Hey everybody, welcome to Functions and Equations Day 2. Today we're looking at Chapter 8, Lesson 3, Functions and Equations. And we're still focusing on this standard. Yesterday we looked at how variables change in relationship to one another. Today we're going to add on to that. And we're going to focus on the next part. Write an equation to express one quantity, thought of as the dependent variable, which we know is the y, in terms of the other quantity, thought of as the independent variable. So basically we're writing equations today, looking at the relationship between dependent and independent. Remember, dependent is the y variable, that's our output. And the independent is the x, which is the input. So we're going to look at the relationship between the two and write an equation about it. So we're looking at functions and equations. I am on page 595. And the first thing you'll see, guys, is that it says it's not just a function, it's a linear function. And remember, I've told you guys, mathematicians and scientists, there is no tricks here. What do you think a linear function refers to? What does it create? Yep, it's a line. It's a line. So a linear function is one that will produce a straight line on a coordinate plane. So it's a function, and I'm getting this from the textbook, guys. It's a function whose graph is a line. Isn't that fancy? Is a line. So simple, so straightforward, and yet so elegant. And so how do we pull out an equation from the data that we get? So I'm looking at the example at the bottom of that page. The table shows the amount of money Carly earns based on the number of hours she babysits. So here's the table. I'm going to write example here. She earns money based on the hours she works, which makes sense, right? Earnings. Okay, so just by looking at this graph, guys, based on the hours, this is how much she earned. So we know this is the x input, and this is the y, which is the output. And we're given the data. So yesterday we had the function, and we either had the input or the output. Today what we're looking at is data. So we have 1 hour, 2 hours, 3 hours, and 4 hours, and we have she earned $6, 12, 18, and 24. Now, your job is to look at the relationship between the input and the output and find what connects them, right? That's what's going to give us the function here. So if I see 6 and I started out with 1 is the input, I know I can do 1 plus 5 gives me 6. I can do 1 times 6 gives me 6. So there's a lot of options if you're looking at the first one. Move on, look at the other ones. How do I turn that 2 into a 12? Well, I know I can multiply 2 times 6 to give me 12. I know I can multiply 3 times 6 to give me 18. 4 times 6 will give me 24. So does it seem like that idea of multiplying the input, x, to get the output, does it hold up? 6 times 1 gives me 6. So then I can conclude, guys, that the function here would be 6x. I'm going to squeeze it in right here. 6x. Okay. And that's how you want to go about figuring out the function. You want to look at the input and how each one relates to the output. The same rule has to hold up across input and output. So let's look at the next page. Let's look at some examples. So I'm going to skip down to the got it problem on page 596. The problem is giving me a table, and my job is to figure out what the function is. So here's the table. Here's example. And I'm going to say got it from page 596. Okay, so the data I have here is I've got my input, x. I've got my, I'm going to leave a space in here in the middle. That's not how it is in the book, guys, but I'm going to put it here just to keep with the same structure we worked with yesterday. So I have my input, I have my output, and the data I have is the input is 1, 2, 3, 4, and 5. The output here is 16, 32, 48, 64, and 80. Now what you want to do is look at the relationship across input and output. So it's easy enough, right? If you start with the 1, go to the 16, well, that could be 1 times 16. That could be 1 plus 15, right? But the thing is, it has to hold up across relationships. So I've got the 2 and 32. Can I do 16 times 2 and get 32? Similar to the previous example, right? If I can do 3, let's go back. If I do 2 plus 15, will that give me 32? No, so that's not an option. Can I do 3 times 16 and would that give me 48? Yes. 4 times 16 would give me 64 and 5 times 16 would give me 80. So I could say that the function is 16x, right? Because 16 times 1 gives me 16. 16 times 2 gives me 32, and so on, right? It has to hold up regardless of the input value that we substitute there. It will still hold up. Okay, so simple enough, guys. You're looking at the relationship between input and output to help you calculate the function. Okay, and you know the last part is the graphing aspect of our work. Here are our xy coordinates. So we have our plotting value. So we have 116, we have 232, and now you're set up to be able to represent your function on a graph. 4 and 64. And incidentally, guys, this is related to tomorrow's lesson. We are also using tables and graphs to represent functions and data. Okay, so if there are no questions about that, and if there are, you can't ask me right now, right? You'd have to go to Schoology, Remind, ask me there. I'm going to move on to one more example, guys, and that is, what if I get a function but no data? Okay, and I'm looking at page 597. These are the two got it problems, B and C. Okay, so what if the question is different? What if I have a function that looks like this, y equals x plus 1, and my job is to plot it, to draw a graph for it? How do I go about that? Well, you can simply input values, guys. So here I have a function, right? And so I can set up my table, input, function, output, right? So my function here is y equals x plus 1. But what do I do here? I don't have any input or output. No, but you can decide, just choose some values, right? Similar to the first two tables, guys. What if we had a 1, a 2, a 3, and a 4? All you have to do is substitute into your function. So basically, guys, my function here, y is going to be, equals x plus 1 is the entire function. But I'm going to substitute the value of x, 1 plus 1, is going to give me my y value of 2, right? 2 plus 1, and so on. So all you have to do here is substitute. And 4 plus 1, and my y values are 2. Here I have 3, 4, and 5. And there you go. Is it wrong to choose 1, 2, 3, and 4? Absolutely not, because you can work with these values, these x-coordinate values, and then you'll be plotting them after that. Don't forget to write your coordinate pairs here on the side. My x is 1, y is 2, x is 2, y is 3, x is 3, y is 4, and x is 4, and y is 5. Okay, let's meet in Schoology for your practice problems. And any questions, guys, make sure you ask me. Not in the comments below, because I know you can't comment, but send me your questions.